Fireworks. These amazing displays of brilliant colors and massive explosions in the sky have left humanity looking up at the sky with wonder and awe since the beginning of recorded history. Why are fireworks so mesmerizing? The sudden bright moving sparks they emit are compelling to watch and seem mysterious because we are so unused to seeing these almost otherworldly stars in our sky, grander, brighter than anything that we have ever seen there before. But fireworks have some very interesting chemistry to them. Why do we love fireworks so much? How are they made? And what produces their brilliant colors?
Around 800 AD, a Chinese alchemist mixed sulfur, charcoal, and potassium nitrate. The mix caught on fire, and gunpowder was born. When the powder was placed in a bamboo, history discovered its first fireworks. In making fireworks, metal salts are put in the star's small clay or dough lumps, 3 to 4 centimeters in diameter. Stars include a blend of oxidizing agents, reducing agents, color agents, and binders. Italian inventors added various metals to create colors with the fireworks, including red, orange, yellow, blue, and purple.
Fireworks are classified as both a low and high explosion. When the firework is shot into the sky, that's when the lowest explosion occurs. Now, when the fuse reaches the end, the high explosion detonates, producing a loud explosion plus the bright colors, which are produced by the metallic cell compounds inside the firework.
Black powder, as we know it, is made up of potassium nitrate, charcoal, and sulfur with a 75-15-10 ratio. The colors from fireworks come from various metal salts. For red, there's strontium. For green, there's barium. For blue, there's copper. For silver, there's magnesium or titanium or aluminum. For orange, we use calcium, and for yellow, we use sodium.
Our reaction for fireworks is fairly complicated. As you heard earlier, fireworks are made up of 3 different components. We have potassium nitrate, charcoal, and sulfur. So here we have our fully written out chemical equation with all the combustion products in it. Potassium nitrate, charcoal, and sulfur. Our reaction products, the reason why black powder produces smoke is because of these particular reaction products that are mostly solids at room temperature. We have potassium carbonate, potassium sulfate, and potassium sulfide. And as gases, we get carbon dioxide, carbon monoxide, and water vapor, as well as atmospheric nitrogen.